Alright, this is part 1 of our review of polynomials. This video is going to focus on factoring. What is the first step of factoring, you guys? GCF. Looking for the greatest common factor. Do you see the common factor here? Hopefully you see that both of these are divisible by 3. That is the greatest common factor. When you see a common factor, you write it in the front and you make a set of parentheses. If you're wondering what goes inside the parentheses, you divide by your GCF. Alright, so these are going to cancel. Excuse me. And this is going to leave 3. Okay, so is there anything else that can be factored, or are we done? Yeah, that's it. This is the answer for problem number 1. Okay, just a little GCF action. Look at number 2. What is the greatest common factor going on right here? Is it 8? No, 8 doesn't go into 18. What about 4? 4 didn't go into 18 either. I guess 2. 2 is the greatest common factor. So let's pull out a 2 and then see what's going to be on the inside. Once again, once you have your GCF, divide by it. So that's going to give us 4y plus 9. Look inside the parentheses. If you see a GCF inside there, you know you didn't pull out a big enough number. But 4 and 9 have nothing in common, so we did a good job. Alright, let's take a look at number 3. Okay, what is common between these 3 things? They're all divisible by 3. So let's definitely pull out that common factor right now. So if I pull out that 3 and make one set of parentheses, so now I'm going to divide everything by 3, don't you know? So that's going to give me 2n squared plus 4n plus 5. Now looking at this trinomial, we need to look and see if we can factor this further. So let's keep this 3, but perhaps this trinomial will factor more. If it did, we'd have to look at the 2n squared. That only has one option, 2n times n. Looking at the 5, that only has one option, 5 and 1. Or it could be 1 and 5. Well, let's try this first. Remember, inner plus outer has to equal the middle. Inner, I have 5n. Outer, I have 2n. Is there any way I can get 4n out of that? Nah, that would make like 7 or 3. So the only thing I can try is rewriting these the other way around. I can try putting the 1 here and the 5 here. I can already tell this is not going to work. Inner, I have 1n. Outer, I have 10n. That's not going to give me 4. So I tried everything that is possible, and nothing worked. So that means that this trinomial is unfactorable. So that's all we could really do, is pull out that GCF. So we are done. Okay, how about number 4? Now I see something common. See all those y's? Both terms have y's in them. Go with the lower amount, okay? 2 y's. Both terms have at least 2 y's. So that means I can pull out y squared as my GCF. But then I need to divide by y squared. Y to the third divided by y squared is y. Now y squared divided by y squared is 1. Anything divided by itself is 1. Oh, boo. Okay, I was just trying to move it down a little bit. Whatever. And there's nothing else to factor, so that is going to be the answer to number 4. Okay, take a look at number 5. What is the greatest common factor of number 5? Well, other than 1, there is no common factor. So that means, looking at the fact that this is a trinomial, let's go ahead and try to factor this as a binomial times a binomial. Now, a squared can only be a times a. Now, 27, the first thing that pops into my head is 3 times 9 is 27. And looking at the 12 here, this is looking pretty good. So let's try that. 3 times 9 is 27. Now remember, inner plus outer must equal middle. Inner, I have 3a. Outer, I have 9a. Is there any way that I can choose the signs so that I will get a positive 12a out of this? Well, yeah. If I do a positive 3 and a positive 9, 3 plus 9 is 12. So that would make this a positive 3 and this a positive 9. So this is the answer. Now, guys, can you tell me why did I just factor and stop? Why am I not going a plus 3 equals 0 and subtracting 3 from both sides and getting a equals negative 3? Why am I not doing that? This is not an equation. If this were like equals 0 or something like that, then I'd be setting these equal to 0. But the directions just said factor completely. So that means factor and stop. So please, on the test tomorrow, guys, don't take a factoring problem and then try to solve it setting things equal to 0. Okay, look at the y squared. There's no coefficient other than 1. So there's no GCF here. So let's just try to factor this as a binomial times a binomial. I'm really not happy with how big that number is, but let's just deal with it and see what happens. Y squared can only be y times y. Now when I look at 110, the first thing I think about is this could be 11 times 10. 11 times 10 is 110. And looking at the 21, this is actually looking pretty good. So 11 times 10 it is. So remember, inner plus outer must equal middle. Inner, I have 11y. Outer, I have 10y. Is there a way I could choose the signs so that I get positive 21 out of this? Sure, if both of these are positive, 11 plus 10 is 21. So that means both of these would need to be positive as well. Is that going to give me positive 110? Sure, a positive times a positive is a positive. So this is the answer. Okay, let's try number 7. Again, there's no GCF. I see it's a trinomial. So let's go ahead and do binomial times binomial. M squared can only be m times m. Now when I look at 33, the first thing that pops into my mind is 3 times 11. So let's try that. Inner plus outer must equal middle. Inner, I have 3m. Outer, I have 11m. Is there a way that I could choose the signs so that I will get a negative 8m in the middle? Well, 11 minus 3 is 8, so that gives me a lot of hope. If I have negative 11 and positive 3, that will give me negative 8m. So if I want a positive 3, there it is. And my negative 11, there it is. Now, will this give me negative 33? Well, yes, positive 3 times negative 11 is negative 33. That means that this is, in fact, the answer. Alright, no GCF on number 8, so let's go ahead and binomial times binomial. C squared can only be c times c. 1 can only be 1 times 1. Inner plus outer must equal the middle. So inner, I have 1c. Outer, I have 1c. Is there a way I can pick the signs so that I will get a middle of negative 2c? Yes, if both of these were negative, negative 1c plus negative 1c is negative 2c. That means both of these would be negative. Got to check one last thing. Are we getting positive 1 when we multiply? Well, yes, a negative times a negative is a positive, so that checks out as well. So this is factored completely. If you wanted to, you could also write c minus 1 squared. Okay, how about number 9? I see a number here. Is there a GCF? No, 11 is a prime number, so nothing's happening there. So let's go straight for the binomial times a binomial situation. You start by looking at the 3x squared. 3x squared can only be 3x times x. There's no other way to factor that. Next, we jump over and look at the 10. 10 can either be 2 times 5 or 1 times 10. That's it. Let's start with the 2 times 5. Remember, inner plus outer must equal middle. Inner, I have 2x. Outer, I have 15x. Is there a way I can get 11x out of this if I pick the signs right? Nope. If I made this a negative 2x, I would get 13. It's close, but it's not the right answer. Let's try just flipping these around before I get too crazy. Let's try putting 5 here and the 2 here. Now let's look at the inner, outer, middle situation again. Inner, I have 5x. Outer, I have 6x. Is there any way I can get positive 11x out of this? Yeah. If I just make them both positive, 5x plus 6x is 11x. Okay, that means both of these would be positive. Is that going to give me a positive 10 when I multiply? Yup. Positive 5 times positive 2 is positive 10. So it checks out. Okay, so this is, in fact, the answer. Alright, let's take a gander at number 10. This one has a common factor. All of these are divisible by 3. So let's pull that out and see what happens. Okay, so if I divide all of these by 3 like you do, I'm going to have m squared plus 6m plus 8. Alright, 24 divided by 3 is 8. Now, the last time I pulled out a GCF, the remaining trinomial was not factorable. Let's give it another try. Still have that 3 hanging around. Okay, let's try factoring this down. M squared is m times m. Alright, looking at the 8, the first thing that pops into my head is 2 times 4. But it could also be 1 times 8. Let's try the 2 times 4. Okay, inner, I have 2m. Outer, I have 4m. Is there a way I can choose the sign so that I get a positive 6m out of this? Yeah, if both of these are positive, that would make 6m. It means both of these would be positive. Is that going to give me a positive 8 right here? Sure, positive 2 times positive 4 is positive 8. So there you go, we just factored it. Genius, we're a bunch of geniuses. And that is the answer. Again, do you understand why I'm not setting these factors equal to 0? Okay, this is not an equation. We're just factoring, that is all. Okay, take a look at number 11. Is there a common factor here? I don't see one. 23 is prime, so Let's go ahead and rock the binomial times binomial. 5c squared can only be 5c times c. But jump over and look at that 18. 18, let's see, it could be 3 times 6, or it could be 2 times 9, or it could be 1 times 18. Alright, I think that's all of them. 18. Okay, because there's a number in front, I can't just look for the 23 right now. Alright, I have to put them in and do inner plus outer equals middle. So let's start with 3 times 6 and see how that goes. Inner, I have 3c. Outer, I have 30c. If I subtract, that would give me 27. That's sort of close, but no good. Alright, let's try switching those before I give up on them. So let's try putting the 6 here and the 3 here. Now, again, inner plus outer equals middle. Inner, I have 6c. Outer, I have 15c. If I add these up, that's 21. Close, but still wrong. Alright, so that means the 3 times 6 option is not working for us. Okay, let's try 2 times 9. Alright, hopefully you can see why you need a pencil for this, not a pen. Inner, I have 2c. Outer, I have 45c. Okay, that's way too big. That's not gonna, even if I make this minus, it would still be 43. Too big. Okay, did I try it both ways? 9. I think I tried it both ways. I don't actually remember. But let's move on. Now, I would try the 1 and the 18. Inner, I have 1c. Outer, I have some big number. It's going to be too big. So let's try doing the 18 here and the 1 here. Inner, I have 18c. Outer, I have 5c. Is 18 plus 5 23, you guys? Well, look at that. It is. If both of these are positive, that will give me 23c. That means both of these have to be positive. Is that going to give me a positive 18 if I multiply? Yes, positive 18 times positive 1 is positive 18. So that's it. That's a very strange factoring problem. 18 times 1, you don't see that every day. Okay, this video is getting a little long. Let me look and see how close we are to being done with factoring. Alright, 11, 12. Alright, we just got 3 more. Okay, let me see if I can do these kind of quickly maybe. There's a common factor here. It is 2. We need to pull that common factor out. Okay, if I do, that's going to leave behind x squared minus 4. Alright, but this is the difference of 2 squares. It's going to factor more. That's going to be x plus 2, x minus 2. Okay, and this 2 in the front comes down. So that is completely factored. Don't stop here. Okay, 2 more. I do not see a common factor, but I'm noticing that both of these are perfect squares and the variables are both squared. So guess what? This is the difference of 2 squares. So let's split everything right down the middle. 4u squared will be 2u times 2u. Alright, for the difference of 2 squares, we always have plus and a minus. And 81w, well, that's 9w times 9w. So there you go. Difference of 2 squares. Something plus something times something minus something. Just split everything down the middle. Last problem. There is no GCF here. Okay, 9 doesn't go into 100. So I start thinking about factoring. It's not a trinomial. Okay, so I can't do a binomial times a binomial. That only works for trinomials. it's not the difference of two squares. If this had been 9t squared minus 100, we wouldn't be having this conversation, because I already would have been like, oh, 3t plus 10 times 3t minus 10, what? But it's not minus, it is plus. What do you think about that? Hopefully you said something like prime or unfactorable. Okay, yeah, it's prime. You can't factor the sum of two squares, so don't try. Alright, if you see the sum of two squares on your test, just write prime and move on. Don't be fooled and tricked. Okay, alright, this video is long enough. That's the end of the factoring part of the practice test. So with part 2 video, we will take a look at completing the square. Okay, we're going to do a lot with completing the square when we return. Alright, I hope this is helpful to you guys. See you in the part 2 video.